Okay, so starting off with, I think it's section 7.3, which is midpoint and distance formula. Okay, both of these formulas will be given to you on your exam. The distance formula is the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And the midpoint formula is an actual ordered pair, x1 plus x2 divided by 2. And then the y part of that ordered pair is y1 plus y2 divided by 2. To use these formulas, you have to have two ordered pairs. So you're given an x1, y1, and an x2, y2. And the distance formula tells you the distance between those two ordered pairs. The midpoint formula tells you the middle of those two ordered pairs, and that's given as an ordered pair. Okay, so we're just gonna do a few problems. I'm gonna give you a few two ordered pairs, and we're just gonna find the distance and the midpoint from both of them. Okay, so let's start off with the ordered pair -2, 5 and -6, 4. Okay, so we want to find the distance and the midpoint between these 2 points. So let's go and label them. I'll label them x1, y1, x2, y2. And we're going to plug them in our formula. So when we go to plug them in our formula, for the distance formula, the distance equals the square root of x2, which is -6, minus x1, which is -2, squared, plus y2 is 4, minus y1 is 5, squared. Okay, so we need to do what's inside the parentheses first before we square it and then put the square root. So I need to do -6 minus -2. Minus a negative is the same thing as plus a positive. So -6 plus 2 is -4. And then 4 minus 5 is -1. So I'm left with the square root of -4 squared plus -1 squared. So now I need to square each of these. I need to add them together, and then I take the square root. When you square each of them, if you square a negative number, what happens to it? It turns positive. So you're going to end up with positive numbers inside the square root every time, no matter what. So -4 squared is 16. -1 squared is 1. And 16 plus 1 is 17. So I have 2 answers here. This is one of them. The square root of 17, that's the exact answer. Okay, it's not rounded off. It's not approximated. This is the exact answer. So on Math Excel, if it asks for the exact answer, it's asking for the square root, and that has to be simplified. In this case, we can't really simplify that. We also want an approximate answer. An approximate answer is a decimal, right? Rounded off. So I'm going to do the square root of 17. Nope. And that is 4.1. Sorry, you can't say that very well. 4.123 is the approximate answer there. So that is the distance formula. Let's go ahead and do the midpoint formula now. I'm gonna turn the page so I'm gonna rewrite it. -2, 5. So -2, 5, and -6, 4. We're finding the midpoint between these 2 points. So again, they're labeled x1, y1, x2, y2, and I plug them in. I get x1 plus x2 divided by 2. So -2 plus -6 divided by 2. The y part of the ordered pair is 5 plus 4 divided by 2. And we can work these out. -2 plus -6, excuse me, is -8 divided by 2. 5 plus 4 is 9 divided by 2. And we can simplify that. -8 divided by 2 is -4. 9 divided by 2, you could leave it as 9 divided by 2, or if you wanted to, you could write it as a decimal. As a decimal, it would be 4.5. So -4, 4.5. And that should kind of make sense. The point directly in the middle, if you look at your x value, the number in between -2 and -6 is -4. And the number in between 4 and 5 is 4.5. Okay. Questions about that? Either one's fine. If I was like actually going to graph this, I'd probably do the decimal. Like it's easier to graph a decimal than it is a fraction, but it doesn't matter. I don't know the answer to that. Yeah, I don't know. Okay, so let's do one more of those. A different set of ordered pairs. This is number 2. If I had 3, 8, and -2, -1. We want to find the distance and the midpoint between these 2 points. Why don't you take a minute and get started on that on your own, find the distance and midpoint, and we'll go over it together. Okay, so when you're doing the distance formula here, you should get, when you plug it in, it should be -2 minus 3 squared plus -1 minus 8 squared. -2 minus 3, -1 minus 8, yes. Okay, so then you get -5 squared plus -9 squared. -5 squared is 25. -9 is squared is 81. And 25 plus 81 is 106. And that does not break down to take anything out. So that's the exact answer, is 106. And then the square root of 106 is, we got 10.296, want to round it? Questions about the distance formula there? A common mistake here, or there's two common mistakes. One common mistake is saying, oh, -5 squared is -25. And -9 squared is -81, or just making one of them negative and then it messes up your answer. Another common mistake here is, like, at this point people say, oh, well, let me just take the square root off and then it's -5 plus -9. Okay, this doesn't cancel out because I have this plus sign in the middle. I can't just take the square root of two things added together. So even if you did that, and let's say they end up with positive numbers, even if you did 5 plus 9 to get 14, that's still way far off from your answer. So make sure you square them, add them together, and then take the square root of that number. For the midpoint, it is x1 plus x2 divided by 2, so 3 plus -2 divided by 2, and 8 plus -1 divided by 2, which would be 1 divided by 2 and 7 divided by 2. Again, that is a sufficient answer. Or you might want to do a decimal. If you did a decimal, it'd be 0.5 and 3.5. And that would be the answer. Questions about that? Okay, that is distance formula and midpoint formula. We are going to move on to the next section, which is 7.2, which is rational exponents. What does rational mean? Anybody know? For a number to be rational, it means it can be written as a fraction. So these are going to be exponents that are fractions. Okay, so if we have some base raised to a fractional exponent, so I'm going to say m divided by n. That represents two different things going on in that problem. The m represents the power that the exponent's raised to. I'm sorry, that the base is raised to. So if that was like a 2 on top, it'd be a squared. If that was a 5 on top, it'd be a to the 5th. If it was a 9 on top, it'd be a to the 9th. The number on bottom represents the root that we are taking of it. So if there were a 2 on bottom, I'm taking the square root. If there was a 3 on bottom, I'm taking the cube root. If there's a 4 on bottom, I'm taking the 4th root, so on and so forth. Okay, so it's a way of writing a power, like an exponent and a root in the same, like at the same time, in a nicer looking way, essentially. Okay, so let's do a few of these problems. So if I had 4 to the 1/2 power, let's write what that means. The 1 on top says I'm raising 4 to the 1st power, okay? The 2 on bottom means I am taking the square root of that problem. Okay, so it's the square root of 4 to the 1st power. What is this? Well, what is 4 to the 1st power, first of all? Just 4, right? And so what's the square root of 4? 2. So this equals 2. We had 27 to the 1/3 power. Okay, I'm raising 27th to the 1st power. What does the 3 on bottom mean? It's the cube root of 27. So the 1 on top means it's raised to the first power. The 3 on bottom means I'm taking the cube root of it. And what is the cube root of 27? 3. What about if I had x to the 1/4 power? That means I'm going to take x, I raise it to the first power, which doesn't change anything. What does the 4 on bottom mean? I'm taking the 4th root of it. Okay, so it's a square root with a little 4 on the index. Do I know what the 4th root of x is? No, so that's just your answer. Okay, what about if I had like 0 to the 1/5 power? What does that mean? Take the 0 and raise it to the, I'm sorry, not raise, or raise it to the first power, but take the 5th root of 0, right? So it's just the 5th root of 0. What's the 5th root of 0? 0, because 0 times itself 5 times is 0. What about if I had 81x to the 8th and all of that is raised to the 1/2 power?
So these are all my champion reserve for this. Basically first, second, or third.
Means everything in the parentheses. What does 1/2 power mean? Just take the square root of it, right? So this just means take 81x to the 8th, and I want to take the square root of it. I could break that down, or what's the square root of 81? 9. And what's the square root of x to the 8th? X to the 4th. So it's just 9x to the 4th.
So those are all my ribbons. Thank you guys.
And you Lauren, do a magic trick.
Okay.
Look at this one. What if I had 5y to the 1/3 power?
You got it. Do a magic trick. I got it. Okay. I'm about to show you that you take any card and make it man. I can still see it. Yes. Yo, Sean, stop, bro. Shut up. All right, Sean, now it's your turn. Do a magic trick. All right. Check this out. Watch the deck of cards. We got no
Sorry, 5y to the 1/3 power. What's raised to the 1/3 power? Just the y, not the 5, right? So the 5 is going to stay normal. What does y to the 1/3 power mean? The cube root of y. So it'd be 5 times the cube root of 5. Does that kind of make sense? Okay, so all of those had a 1 on top. Let's do some that don't all have a 1 on top, okay? So if they don't have a 1 on top, there's going to be 2 things happening, and it doesn't matter what order you technically do, okay? So let me kind of show you. If I had a to the n over m power, I could write this as a to the n power, and it's the mth root of a to the m. I mean, it's kind of weird to say it, but m is the root, n is the power. That's one way to do it. Or you could do the root first and then raise it to the power last. It doesn't matter. You're going to come out with the same answer. This way is usually easier. And I will show you what I mean by that. The pen's running out. Okay, so let's do 16 to the 3/4 power. What's the power that I'm raising that to? The 3rd power. And what's the root that I'm taking of that? the fourth root. Okay, so again, the two ways you could write this, you could write this as 16 to the third power and then take the fourth root. Or you could write it as the fourth root of 16 and then raise everything to the third power. It doesn't matter how you write it. This one is easier, and here's why. If I do this one, I have to do 16 to the third power. Do you know what 16 to the third power is? Me either. So like you'd have to do that 16 times 16 times 16, and you get 4,096. And once you get 4,096, then you take the fourth root of that. Do you know what the fourth root of 4,096 is? Me neither, right? Like those are just really big numbers. So usually if you do it this way, you get big numbers. And it's kind of hard to work with those numbers. If you do it the other way, first thing I want to do is take the fourth root of 16. That means what times itself 4 times gives me 16. Or if I break down 16, do I have a group of 4 of something? Okay, so we can do that if we needed to. 16 is 4 times 4, and each 4 is 2 times 2. Do I have 4 of the same thing here? Yeah, 4 2s. The fourth root of 16 is 2. And then 2 to the third power, what's 2 times 2 times 2? 8. So you can see how you can do it that way in your head, and this way I can't do it in my head. It's actually really hard to do with the calculator also. Okay, let's do more of those. 9 to the 3/2 power. Okay, so what power are you raising 9 to? The third power. What root are you taking of 9? The second root or the square root. Okay, so it's best if you do the root first. So the square root of 9, and then after we're done with that, let's raise it to the third power. What is the square root of 9? 3. And what's 3 to the third power? 3 times 3 times 3 is 27. And that's your answer. Okay, this whole idea is one way you can write like fourth roots and fifth roots and sixth roots in your calculator. If I want to take the fourth root of 16, I don't really have a button that says the fourth root. I mean, there is a way to put it in there. It's just a lot of buttons. So it's easier to write it as 16 to the 1/4 power. And it'll tell you that's 2. Okay. Let's do a few more of those. What about if I had the problem -27 to the 2/3 power? Okay, so what power are you raising that to? The second power. What root are we taking? The third root. So this is the cube root of -27. And then when I'm done with that, I'm going to raise it to the second power. What's the cube root of -27? -3. And then when I square it, what is -3 squared? +9. Questions about that? What about if I had -1 to the 3/5 power? What root am I taking here? The 5th root, right? So it's the 5th root of -1, and then I want to raise that to the 3rd power. What's the 5th root of -1? Just -1, right? It's an odd root, so I can just put the negative on it. And then when I raise that to the 3rd power, what's -1 to the 3rd power? Just -1. Questions about that? Okay, so we can apply exponent rules to this. So like, I can make this a negative exponent up on top. I can, if the bases are the same, I can add exponents together. If the bases are the same and they're like divided, I can subtract exponents. So the exponents rules we've been learning, we can apply to this idea. So let's do some of those. What about if I had the problem 16 to the -3/4 power? What does a negative exponent mean? Or what do you have to do with a negative exponent to fix it? Move it to the bottom. So this whole thing is on top of a fraction. I need to move it down to the bottom. So it becomes a 1 on top over 16 to the 3/4 power. And 16 to the 3/4 power, I can write using roots and powers. What's the root here? To the 4th root. So it's going to be 1 over the 4th root of 16. And then I'm going to raise that to the 3rd power at the end. What is the 4th root of 16? 2. And then I have to do 2 to the 3rd power. What is 2 to the 3rd power? 8. So my answer is 1 over 8. What about if I had 25 raised to the -3/2 power? Again, it's a negative exponent, so you need to move it down to the bottom of a fraction. So it's 1 over 25 to the +3/2 power. 3/2 power, which one's the root, the 3 or the 2? The 2, so it's the square root of 25. And then when I'm done, I'm going to raise that to the 3rd power. The square root of 25 is 5. And 5 to the 3rd power is 125. So my answer is 1 over 125. Okay, so that's using the negative exponent rule. We can use other exponent rules. What about if I had the problem b to the 1/3 power times b to the 5/3 power? What exponent rule would I use here? Yeah, you would add your exponents. It's the product rule. The bases are the same, so I can just add my exponents together. So this becomes b to the 1/3 plus 5/3. To add fractions, remember you have to have a common denominator, which we have in this case. Once you have a common denominator, you just add across the top, keep the bottom number the same. So this becomes b to the 1 plus 5 is 6 over 3. And what is 6 over 3 reduced to? 2. So it's b squared. Questions about that? What about if I had 7 to the 1/3 power on top divided by 7 to the 4/3 power on bottom? Yep, you'd subtract your exponents here. So this becomes 7 to the 1/3 minus 4/3. Again, I have a common denominator. So I'm just going to do 1 minus 4. What's 1 minus 4? -3 over 3. And what does that reduce to? -3 over 3? -1, right? And can I have a negative exponent? How do you fix it? Move it to the bottom. So it's going to be 1 over 7 to the positive 1, or just 1 over 7. Questions about that? Okay, let's kind of go back and forth between radical exponents and rational exponents. So for these problems, we're going to write using rational exponents and simplify. Okay, so if we had the problem, the 9th root of x to the 3rd power. So we want to write that using rational exponents. So my base is x. The exponent is going to be a fraction. The number on top is going to be the power that it's raised to. The number on bottom is going to be the exponent. So what would be the fraction here? 3 over 9, because the power here is the 3rd power. The root is the number 9. It's the 9th root, so it's going to be 3 over 9. Can I reduce that? 3/9? Yeah, it's 1/3, right? So x to the 1/3 power. You could write your answer like that, or if it asked you to write it in radical notation, let's put it back as a root. What's the power and what's the root here? Power is 1. I'm taking the cube root here. So it's the cube root of x. Isn't that a lot nicer looking than the 9th root of x to the 3rd power? Okay, let's do another one like that. What about if I had what about if I had the 4th root of x to the 6th power? If I wanted to write that using rational exponents, my base would still be x. What's the fraction that x would be raised to? 6 over 4, power on top, root on bottom. So 6 over 4, can I reduce that? Yeah, x to the 3 over 2. You could write it like that, or if it asked you to put it back as a radical, what root am I taking here? The square root of x to, what's the power for x? 3. And that would be your answer. Questions about that? Okay, so let's kind of put both of those things together. This whole writing it with rational exponents and then using exponent rules to kind of simplify it. So if I had the problem, the square root of x times the fourth root of x. Okay, so you can't do anything with them how they are. So what we need to do is we need to rewrite using the rational exponents, because then I can do something with them. How would I rewrite this square root of x with rational exponents? X to what power? The 1 over 2, because this is the square root of x. Times the other one, x to the 1 over 4. Everybody tracking so far? Okay, so now they have the same base. What am I going to do with the exponents here? Add them, so it's x to the 1/2 plus 1/4. To add these fractions together, do they currently have a common denominator? No. You could do it on a calculator, or you could come over the side of your paper and get a common denominator. What's the common denominator going to be here? 4, right? So this one's a 2, this one's a 4. So I need to turn the first one into a 4. You could do 8 also, but you'd have to reduce it at the end. So this becomes 2 over 4 plus 1 over 4. Now they have a common denominator, so I can just add across the top, keep the bottom. 2 plus 1 is 3. The bottom stays as 4. So 1/2 plus 1/4 is 3/4. So this becomes x to the 3/4 power. That's one way to write your answer. What's the other way to write your answer here? What's the root and what's the power? Yeah, it's the 4th root of x to the 3rd power. Questions about that? Let's do another one of those. What about if I had the square root of x divided by the cube root of x? First thing we're going to do is rewrite it using rational exponents. On top, how do I write the square root of x with an exponent? X to the 1/2 power. On bottom, how do I write the cube root of x with an exponent? X to the 1/3 power. What am I going to do with those two exponents? Subtract them, because it's the quotient rule, so it's x to the 1/2 minus 1/3. Again, you can do that with a calculator, or I'm going to come over on the side and get a common denominator. 1/2 minus 1/3. What's my common denominator for 2 and 3? 6. So I need to multiply the first one by 3 to turn it into a 6. The second one I'm going to multiply by 2 to turn it into a 6. So 3 times 1 is 3. 2 times 3 is 6. So 1/2 is 3/6. Minus 2 times 1 is 2. 2 times 3 is 6. So 3/6 minus 2/6 would give me 1/6. So my answer is x to the 1/6 power. Or how can you write that as a radical? The 6th root of x. Questions about that? Okay, we are going to stop there. We will review this on Monday and move forward with our lesson on Monday, and I'll have your test back for you on Monday. Let me know if you have any questions.